Okay, let's get started. It's just pretty much bang on 8 o'clock. So thank you for those of you who are here for making the effort to get up for 8 o'clock in the morning. It's an early shift, I have to admit. So for those of you who don't know me, my name is Paul Carter, and I've worked at Metaswitch for about 10 years. First half of which I spent managing the development of our fixed line voice products, but since then in the networking software team, where I now lead the product management function. Through that time, as several of you know, I've been an advocate of network disaggregation, and in the first half of today's talk, I'm going to explain why I feel that disaggregated networking is finally coming to telco networks, and why building an open portable NOS is a great opportunity for both traditional OEMs and newer software providers. And then in the second half, I'm going to cover Metaswitch's contribution to OCP at this summit, and how it explains what you need to do to build a network operating system using white box hardware for telco networks. First of all, for those of you who aren't familiar with us, a quick explanation of who Metaswitch are. Fundamentally, we provide the networking part of a network operating system. Our customers are traditional OEMs and newer software providers who are building network operating systems to run on either or both traditional proprietary hardware or white box hardware. We supply the source code that has the implementation of carrier-grade networking protocols and the services that support them, integrated right from a CLI and netconf interface at the top, down through the services to integration with hardware SDKs and open interfaces at the bottom. We've been doing this for a long time now. We've worked with numerous customers across a wide range of applications, from the data center through to service provider networks, campus enterprise, and even embedded satellites and military type of applications. In short, we consider ourselves to be quite experienced at this, and we wanted to share some of that experience with the community. We've also been involved with the OCP for many years. In 2016, we demonstrated our control plane integrated with the OCPSummit19 running on Mellanox hardware. And we've also contributed to the SAI project through the SAI tunneling proposal, which we also did in conjunction with Mellanox, and we also submitted the SAI fast reroute proposal. So moving on, let's look at where disaggregation is today and the challenges it faces in telco networks. Over the last few years, disaggregation has brought many benefits to the industry. It began with server compute space and allowed operators to gain massive CapEx and OpEx savings through automation and standardization. More recently, this has extended to data center networking, where operators have been able to take advantage of the latest hardware capabilities and software innovations, and do so much quicker than in the old world of monolithic routers. Outside of the data center, this hasn't really happened yet. This is because networking growth in the wide area network is more about extending existing networks, which are very complex, than building brand new ones. And so the barrier to change is much higher. However, service providers are starting to demand that they also reap these benefits. For example, I'm sure that some of you will remember that at ONS last year, Andre Fuchs made it clear that white box routers are a key part of AT&T's rollout strategy for 5G, and that they are investing heavily in the DNOS operating system as an open NOS to support their network requirements. So telco network disaggregation is happening, but it's not just AT&T. All of the tier ones are looking at this at the moment, and the transformation required by the rollout of 5G is going to be huge, incredibly complex, and immensely costly. So all of these operators are looking at ways to simplify that rollout by using automation, and to drive down costs by leveraging white and bright box hardware. At Metaswitch, we also have other evidence. A few years ago, all of our conversations with customers were with traditional OEMs building monolithic equipment and the operating systems that went on that. Now those conversations have shrunk dramatically, and most people we speak to are actually looking to build disaggregated and portable network operating systems. And just recently, there have been various different product launches from the likes of SnapRoute, Adver, Infinera, and Arcus of disaggregated networking operating systems targeting some of the devices in telco networks. So let's look at what telcos need from a disaggregated router in order to deploy them and how this differs from what's needed in a data center. It boils down to two things, function and reliability. At the basic end of the scale, you have a router within a data center. It typically only needs simple routing protocols and some layer 2 function. Low-cost white box hardware and open source OSs like Sonic and OpenSwitch, along with open source routing software such as Quagga, Bird or FRR is suitable here. As you look at data center interconnect, the options become a little bit more complex, and you've got approaches like Ethernet over MPLS, virtual extensible LAN, and virtual private LAN services, and it's not clear that open source software can supply all of that functionality. The cell site gateway is the next step and really the first step into the telco network, and it's been getting a lot of attention recently as a suitable entry point for disaggregation in telco networks. These devices need faster hardware, deeper packet buffers, and whilst there's certainly white box hardware available, it's, again, open source software routing is just not good enough. It needs to support more routing protocols and is likely to need high availability features. Most routers that occupy this position in the network today support MPLS and for the implementation of layer 2 and layer 3 VPNs. Although it's fair to say that the TIP spec for a disaggregated cell site gateway doesn't necessarily require open MPLS, possibly because there isn't an open source MPLS implementation available today. As we move into aggregation and core networks, white box hardware and open source routing software just isn't good enough. MPLS, high availability, and many other functions are essential. Meeting all, or even most of these requirements is beyond the capabilities of today's open NOSs and control planes. In particular, there are no realistic open implementations of MPLS that support functionality such as LDP with fast reroute and segment routing with TI LFA, and also legacy function like OSVP with one-to-one protection. The complexity of these requirements and the diversity of different network devices in service provider networks means that I think it's unlikely that any single networking operating system is going to emerge to dominate this market. And in fact, I imagine there's going to be an ecosystem of different networking operating systems that target different use cases, but all running on white box and white box hardware and being portable between them. And I see that this is a big opportunity for new software providers and OEMs to take advantage of. Okay, so that's a bit of background to it, and what I want to do now is to move on to the second half of the presentation where I'm going to introduce the NOS cookbook that Metaswitch is launching today. But before I talk about that in detail, I'm going to talk about the architecture that's behind that NOS cookbook. And it's key to building a portable network operating system to have a well-defined architecture and to build that in from the outset. And so the foundation of our proposed architecture is the OCP project Open Networking Linux. And this project provides a common base for a portable NOS using the platform abstraction layer to support all the hardware devices such as LEDs, fans, SFPs, and so on. And this means that porting that aspect of the NOS from one hardware to another can be made a fairly trivial exercise. The second part is the OCP SAI interface, providing a common interface to the switch silicon. I'm sure that many of you know lots about the SAI, and so I'm not going to describe it in detail. But there are obviously many other sessions today covering the SAI for anyone who would like to know more. However, from our perspective, the big advantage of the SAI is that it has been implemented by multiple of the chip vendors. So switching, if you support the SAI, switching to a white box with different switching hardware becomes a real possibility. Above the SAI and the ONL layer lives the control plane, which is where most of the complex logic of the NOS lives. This is in turn split into three areas: the actual control plane protocol implementations themselves, the databases that hold the key networking state information, and finally the components which provide services to the control plane and program those instructions down and program Linux and the SAI accordingly. the very top, we have the management layer, which is where the NOS interfaces with the rest of the world. There are numerous different interfaces expected to be supported these days. NetConf, RESTConf, traditional CLI, and even SNMP is still often needed. And the best way to do that is to integrate with a NetConf server, such as OpenUMA, UMA Pro, or Conf-D, and having underlying Yang models to support that. Finally, there's the applications running at the top there in white, and these are the other applications to provide additional functionality to the networking operating system, which might be provided by third-party applications for services such as telemetry, intent-based networking, and so on. They may be applications written by the NOS provider to differentiate their NOS, or apps written by the operator themselves to integrate their devices with the rest of their network. Okay, so moving on to the actual NOS cookbook that we're launching today through the OS OCP. This is intended to be a resource to help OEMs and software vendors looking to build a NOS solution for telco networks. It is available for download today, and I will share the URL at the end of the presentation. The cookbook is split into 3 parts. The first part covers the rationale for building the NOS, targeting telco networks, and the options that you have there. It also covers the architecture I presented on the last slide in rather more detail. The second part includes instructions on how to make a start on building that NOS using OCP and other open technologies, as well as outlining the work remaining to complete the NOS. And then the final part introduces the Metaswitch NOS toolkit, which I'll speak about more in a minute, which includes many of the components that you require to build a carrier-grade networking operating system for telco networks. Of course, the instructions in there don't provide everything you need to build a networking operating system, and there are decisions that you need to make and more work to be done, code to be written. Decisions like deciding the specific use cases to target, the protocols you're actually going to need to support, the hardware you're going to support, architecture, threading model, that type of thing, and the management interfaces. Oh, it's gone too far. Okay, so now I'd like to move on and show you a short demonstration. Is that actually visible? That's not very visible, is it, on there? I'm sorry. What this should be showing, if the demo is working correctly, is a proof of concept implementation of a networking operating system, leveraging the Metaswitch NOS toolkit, showing MPLS running on a sort of basic network operating system. Before I go into in a bit more detail, here's sort of the network we have set up here. There are 2 control windows on the display. The first of those is the box on the right. I don't know, I can't show the top right-hand box is the bottom command window, and it is showing TCP dump running with ping packets flowing from counterclockwise from the bottom right over the top to the bottom left. And so the top right box is showing TCP dump run of those ping packets that are then going through the edge core device at in the middle, which is the device that the top command window is showing. And that's the one running our networking operating system. At the beginning of the demo, there's no MPLS network set up, and so TCP dump is just showing straight IP ping packets. We then set up an LDP neighbor on the edge core box, and a few seconds later, we start to see those packets labeled with an MPLS label, showing that the MPLS network is then set up. And then finally, we take that LDP neighbor away again, and the MPLS labels go off again. So that's what's happening there. Unfortunately, this was working in my hotel room just a few minutes ago, but doesn't seem to be doing so here. But I can, anybody who's interested, we can set this up and do it live for anybody who are interested. But the key point here is that it shows that it's actually not a massive stretch to set something up like this and make a significant start on setting up a networking operating system that supports MPLS and therefore is more suitable for telco networks. And as an indication, it took our engineers about 3 months of effort to build this. So This slide shows the actual architecture implemented in that demo, which is remarkably similar to the generic architecture I presented earlier. But here we're leveraging the power of the Metaswitch NOS toolkit to supply all those control plane protocols, databases, services, and management components required to power that NOS. The one small difference to the earlier architecture is that we had to use OpenNSL instead of SAI as the interface to the Broadcom SDK. That demo was running on an edge-core box, obviously, and with a Trident 2 chipset in it. The reason for using OpenNSL was that SAI today doesn't support MPLS programming, so we had to use OpenNSL, which does support MPLS. We'd urge people to get involved with the SAI project to help the chip vendors add that MPLS support to their SAI implementations. The Metaswitch NOS toolkit is available today and provides a commercial solution to many of the challenges to building a carrier-grade portable NOS with rapid time to market. It supports all the network control plane protocols required by cell site gateways, access and aggregation routers, as well as data center switches and data center interconnect solutions. It's supplied with a comprehensive set of YANG models integrated with NetConf servers to provide management interfaces required of modern devices. And finally, the architecture supports natively supports containers, microservices architecture, and solutions such as network slicing. As a proof point of the flexibility of the Metaswitch components and their applicability to multiple networking use cases, SnapRouter are leveraging the Metaswitch stack in their cloud-native networking operating system, which is built on an innovative containerized microservices architecture, which is internally managed by Kubernetes. CNOS provides companies with a competitive edge unifying the currently fragmented data center operational model, enables rapid time to service and efficient deployment of applications. So, thank you for your time today. I hope that I've helped to demystify some of the steps required to build a NOS suitable for deployment in telco networks, and that the NOS cookbook that Metaswitch are announcing today will help some of you make strides in that direction. Disaggregation and openness are going to be the requirements from telcos as they begin to plan their rollout of their 5G networks. And this represents an opportunity for OEMs and others to take advantage of. And obviously, we hope that the Metaswitch NOS toolkit can help accelerate the implementation of the NOS to do just that. Finally, here is the link for downloading the NOS cookbook. And if you'd like more information on the Metaswitch NOS toolkit, please talk to me afterwards or go to www.metaswitch.com/networking software for more information. I would also urge, as I said before, anyone interested to join the OCP SAI project and help switch silicon vendors add MPLS support to their SAI implementations, as I think that will be a key enabler for helping move disaggregation into telco networks. So that's it from me. Hopefully I've got just a few minutes left to take any questions. Thank you. Hi, Ariad. No, so the question from Aviad, for the benefit of the recording, was whether or not Metaswitch really have any plans to move into providing a networking operating system. The answer to that is no. We have no intention of competing with our customers, which is what that would be. We are focused on helping our customers build networking operating systems. Obviously, we would like to be providing the control plane protocols that form the backbone of many networking operating systems, but we see ourselves as enabling that as opposed to actually building a networking operating system. And as I said, sort of competing with those customers, I think that would be the wrong approach. And we're not set up to do that. That's not our business model. So yeah, no, we're firmly in the camp of continuing to provide protocols and services as we have done for many years. We've just got a much wider range, much wider portfolio and more integrated solution than we had before. Yes, Tom.
What sort of challenges do you think there are adding MPLS support to SAI?
I think that the question was what sort of challenges do I see in adding MPLS support to the SAI? There, I think it's in part demand is going to be the key driver there. If the vendors, Broadcom, Mellanox and others, see that there is strong demand from customers who wanting to buy their hardware and deploy that into service provider networks, they've then got a strong incentive to add that support. The definitions are all largely there. I'm sure they need a little bit more work before they be fully deployed. But I think it's the demand that needs to be there, and I'm hoping that this talk today will help generate that demand. Oh, yeah, sorry, over there. Hi. So the question was, do we support modular switches or just top-of-the-rack switches? So the MetaSwitch componentry protocols are entirely independent of the hardware architecture. So we will support modular switches as well as top-of-rack single unit type things. We support high availability, graceful restart, supporting stacking solutions using Broadcom chips, for example, is all supported today. Okay. Any other questions? If not, thank you very much, everybody, and it's been a pleasure talking to you.